All right, we are going to talk about with and without replacement in this video. So there's this problem in the book about bad flash drives. We have 10,000 in a shipment and 10 are randomly sampled. The supplier doesn't know that 2% of the flash drives are defective. So first of all, is this a binomial situation? So we have a fixed set of trials. Well, let's go in order. Sorry, let's back up. Bins. So it is binary. It's bad or not, the flash drive. Independence, let's talk about that in a second. It is a fixed number of trials. We have 10. All right, now independence and success. I'm going to say yes because I need some room here. The sample size is small. Compared to the population. N is less than, on the next page there's this little rule we can follow. N is less than 10% of the population. So 10 is much smaller than 1,000 flash drives. Now, I haven't even brought up that rule yet, but that's a nice rule of thumb that we use in stats to prove independence. And since it's such a tiny sample, we have no effect. The thing that we're worried about, and we're going to prove it here in a second, is once we get to, for example, the 10th draw from this shipment of drives, is it still a 2% chance of that one drive being defective? Because like if I have a deck of cards and I draw 10 cards without replacement, my probability of, say, an ace changes by the 10th card if I'm not putting them back. But this population is huge. A deck is only 52 cards. So this is a big difference. So I'm going to say both of these check out. The 10th drive that I draw is still a 2% chance, and we're going to prove it in just a second. So its parameters are binomial. I wrote them up there, but it asks for it again for some reason. N is 10 and P is 0.02. And then let's actually find a probability based on binomial PDF and based on without replacement. So this is kind of tricky. Let's see if we can do it. So P of X equals 0. This is, by the way, ignoring without replacement right here. So I'm going to do binomial PDF and see what I get. I get 0.8171. All right, now let's test it without replacement. So I'm going to ignore binomial. Ignoring binomial properties. So the P of X equals 0 means I'm getting a good flash drive. I messed this up initially in class. How many good flash drives are there? Well, there's 200 bad if 2% of them are bad, right? So that means there's 9,800 good when I first reach into, say, the bag of drives. That's the first draw. I set it aside and I grab another one. This is 0 bad. Probability of X equals 0, drawing 10. So that means I got a good one. So next draw, there are 9,799 left and 9,999 left. So we keep this up, we keep going. Whoops. And we do this till we get 10. Dot, dot, dot. 97, 91, 9991. And interestingly, we get 8170. So, since we get 8170, we can say without replacement did not have a huge effect. I mean, look at our two results, right here and right here. I mean, if that fourth place value bugs you enough, I guess you could do without replacement. But since, one more time, since n is smaller than 1/10 of the population, it had a insignificant effect on the probability. And here's the rule, in case you're interested. N needs to be smaller than 10%, or I guess arguably exactly 10%. So, all right, I will see y'all in class. Bye.